Hello, STPAmaster is now released, so let me briefly introduce the tool and its main features. The tool is designed for real-scale safety-critical systems, so you can use it for complex STP analysis, but it is also designed to be practical, which involves a lot of automation that makes an STPA easy to manage. If you tried the STPAmaster Lite, then this is a new software. It is now a web-based application that implements the features of the Lite version, but also a lot more. So let's have a look at the tool. Now I'm on the dashboard page after logging in, clicking on Analysis. A database of the STP analysis inside the tool displays. And for the video today, I'm going to use the electrical system of Cessna C510 aircraft. This is the overview page of the STPAmaster, which shows basic information about this particular analysis. On the bottom, you can see also the validation feature listing all the issues that require my attention. On top, you can see the supported workflow, which includes the entire STPA from step 1 to step 4. We also have step 5, which is definition of system level requirements or safety constraints based on loss scenarios. From here, you can enter any of the STPA steps. So let's go for step 1. That will show me a list of losses, system level hazards, and system level constraints, and all the information I need to see. On top of that, I can see the validation feature. These are the orange triangle over here. However, a message will display. For example, for H2, the system level hazard is not referenced by any system level constraint. This means I have to add one or perhaps edit the existing. The other says that a hazard should not reference specific causes. As you can see, H4 is a human error, which would in STPA not be a valid system level hazard, but rather something to expect in UCAs or loss scenarios. STPAmaster is checking for these two types of errors. One is the consistency of the analysis, so if things are not missing in your analysis, or maybe if things are not duplicate in your analysis. The other are analysis errors, which are based on common mistakes in STPA from the STPA handbook and MIT presentations. Now, going forward to step 2, this is a new safety control structure editor, which allows drawing safety control structures inside of the tool completely from scratch, but you can still import from Y editor and now also from Enterprise Architect, specifically the SysML v1 XML file. This is STPA created actually from a SysML v1 file. You can see so by the component labels which follow the UML notation. The control structure editor is quite simple. We're focusing on what's essential about any STP analysis. So you can draw controls, control processes, even actuators, sensors. You can do nodes embedding. This means put components into larger components. We streamline displaying the control actions and feedbacks. You see only one edge, which accommodates all the control actions between two components. The same holds for the feedback edges. There's also some automation in here. It's the auto layout feature, grabbing any of the components. When I start moving it around, you would see that the edges would give way to the new, to accommodate for the new layout. But if you don't like the auto layout, of course, you can do manual editing afterwards. There is also the option to define context variables if you are going to use context tables in step 3 of the STPA. So when I click on any of the components, for example, the battery, I can display the context variables. In here is the battery charge, connection, and temperature. Here are the possible values of the variables. Last to mention is that you can export this diagram. You don't see it right now, but there is a button in the bottom right corner. If you hit on that, a dialog will appear asking you where to download the SVG file. Going forward to step 3 of the STPA, this is the definition of UCAs. First, you need to select the controller for which the UCA table would display. Then if you do so, you would see the UCAs, you would see the cross references. If you click on any of these, the full text of the cross-reference items here, the hazard 1.1 with display. You can also display the control constraints either directly inside of the table like this, but that may not always be practical. So there is also other option in here. Clicking this button will show you the same table, but now you see just the control constraints within the UCA table. There's also an option to view or see the safety control structure that relates to this selected controller. If I click the button here, I would see just a subset of the control structure. Specifically, I would see the components and interactions that relate directly to the component, or components which the component is part of. Now, if you want to generate or create UCA, you can do so by clicking on any of these cells. If you do so, a dialog will appear with pre-generated UCA text. Some of the UCA tabs have even options. If that's the case, you can click these buttons over here. For example, like in here, I can choose an option, stops providing too soon. By clicking on these, the text will adjust accordingly. The only thing I have to do is just fill the context and the UCA is defined. The control constraint would be then fully automatically generated based on the text you see and the context you provide. There are other options how you can generate the UCA or create a UCA. You can use the context tables, as I already mentioned in the control structure. Hitting this button will display the context table. Here, the only thing you have to do is click on any cell in the context table, and by providing the link to respective system level hazards, you can create the UCA completely automatically, because the context would be completely defined by the context variables and their respective values in that cell. You can also use the context rules if you want to, adding a new rule for groups of unsafe control actions could, of course, simplify the process and generate many unsafe control actions at once. Going forward to step 4 of the STPA, you can display the loss scenarios table. Again, you have to select for which control or control action you would like to do so, or possibly for all of them. What you see in here is a table of base loss scenarios. So you see the loss, you see the unsafe control actions on the left and the loss scenarios in the table. If you want to generate a loss scenario, then you can do so by, let me give it a few in here. You can do so by clicking on any of the cells inside such table. If you do so, just like with the UCAs, a loss scenario text pre-generates, and you only have to check it or manually edit as you want. You can do it even collectively, generate all the base loss scenarios for respective UCA. Clicking this button would do so for me. There is also the option to define or to refine the loss scenarios. If I edit the base scenario, I can do so by clicking this plus button, basically creating as many refinements as I want. I would then just type in the scenario refinement. If I look at some of the already completed loss scenarios, maybe this one, here's the way a completed loss scenario looks like. That's the base scenario over here. The refined scenarios are down below. There are 4 of them. And noteworthy, there is a specific type of issues you can experience with the scenarios, especially if your analysis has hundreds of them. Things may repeat very easily. The tool will be searching for duplicities in your analysis. I have an example in here which says to me that the refined loss scenario with equivalent description already exists, and it will list me the IDs of the equivalent loss scenarios. So if that's the case, you probably want to further refine these scenarios which overlap, or you may want to consider all of them. In fact, just one refined scenario that is on 3 different places in this particular case in my analysis. Last step to mention or to show in the workflow is the system level requirements, which, as I said, are the safety constraints based on loss scenarios. So what you want to do in here is to display the loss scenarios. Again, I can display them by selecting a controller of here. And now I would like to define the system level requirement. I can do so by clicking this plus button and provide the description in here. But if I pick one of the already existing, as soon as I have defined or selected one of the existing scenarios or existing requirements, I can link it to the loss scenarios via these tick boxes. This way creating the link between the requirement and the loss scenarios. When I'm done, I can display the list of all the requirements based on loss scenarios via this button, which will show me the system level requirements overview. I can see all of them in here. I can see the cross references. Again, clicking on any of them would show me the full text. We also have target components in here, which is the mapping of the requirement back to the control structure. Useful if your model is outside of the STPAmaster, for example, in the enterprise architect, and you would like to have these requirements mapped back on your model. But inside of the STPAmaster, you can use this to filter the requirements. For example, showing the requirement just for the aircraft engine. You can see a subset of 5 requirements with display. In total, the analysis has a few dozens of them, 46 I can see here. That's the entire workflow supported by the STPAmaster. Now I would like to briefly show you some additional features which are very important if you're dealing with complex STP analysis. One of the first to show is management of change. That's useful for cases when things change after the STPA is complete. So, for example, you may want to update your safety control structure. You may, for example, rename a component. For example, battery to become standby battery now. If I do it and try to save, then the STPAmaster would show me this dialog asking what to do. First, listing all the things that already depend on the battery inside of my STPA. Well, obviously I have UCAs, control constraints, loss scenarios that are using the battery as a component. If I want to, I can click any of these and display the full text of respective item. But most importantly, I have to decide what to do. There are 3 options. You can regenerate. This is automatic regeneration of all these items using this new component or new label. That's useful if all these items were automatically generated before. If you did a lot of manual editing, then regenerating the items might not be good because you may lose the manual editing work. Then you would mark obsolete, which would keep them all as they are, but flag them with orange time icon so that you can later find them and manually edit. Or if the edit is really substantial, which requires redoing part of the analysis, then you might want to be deleting all these items and simply redoing the STP analysis. The same would happen with any other item. So I may open a UCA and try to edit the UCA. Again, you would see the list of dependent items and you would have the same 3 options in here. The second feature I'd like to show you is called Traceability. From any of the STPA steps, you can enter other view to investigate or navigate the STP analysis via this button. If I do so, this type of view appears. I've entered the traceability view from this particular UCA. That view will show me all the items that are directly linked to this particular UCA. It won't show me the entire STP analysis because that would be too much, but I can see the most important items related to it, which would be the base loss scenarios, the control of constraint, system level hazards, context variables used within the GCA and their values, and the control action this is based on. You can navigate through this view by clicking on any of the items and clicking trace references. If you do so, the view would change, putting the selected item in the middle. So this is a view for the hazard H2. For the system level hazards, of course, you would be displayed with all the UCAs that are referencing the system level hazard. and the losses that these system-level hazards can cause. There are also filters available in here. These kind of diagrams might be already quite complex, so you may select a particular controller and narrow down the search. You can also exit this view either by going back to the analysis. That would return me to the point from which I have entered the analysis, or you can exit the analysis via any of these in here by clicking Show that analysis. If you do so, here is, for example, UCA32. If I click Showing Analysis, the tool would show for me a respective cell in the UCA cell, and I can continue from here. The next feature I'd like to show is the localization. The STPAmaster supports different languages. You can change the application language in here. There are a few languages supported. You can also select the language of the STPA analysis itself. This was an example of English analysis, but we can show an example of one of the local languages. This one is Czech. So let's go into an STPA analysis done in the Czech language. Here is my safety control structure. As you can see, the control structure is already using Czech labels for the components and interactions. If I then use the automated way of creating or generating the passive control actions, all these would be pre-generated in the local language, and I have local language options as well. The same holds for loss scenarios, which would be also generated with the local language. So if I delete first one, for example, you can see that I can click on this button and all of that would be automatically generated. There are just English and Czech languages supported for the moment for the STPA analysis itself, but of course this is extensible for more. Next feature that I would like to show is when you complete an STPA analysis. I'm going back to my electrical system. When you complete the STPA analysis, you have an option to download the STPA or export the STPA into the Microsoft Excel file. If I click this button here, I will be prompted to download the Microsoft Excel file. If I open the file, then it would look like this. So I will have few tables that include all the content of my analysis. So this is step 1. For step 2, you would even have the interactions components. There would be no diagram in here. You have to download the SVG, UCAs, loss scenarios, all that are just tables that you can download. You can copy the content and compose any report you would like to do from your STPA analysis. That's all what I wanted to show you in this video. I hope you enjoyed.